Wow, I wonder who researches that. A bizarre biologist? A funky physicist? Or sort of kind of periodic table researching? A chemist!
You've got quite a mind in you. I'll make it better by teaching you all about the periodic table. Oh, the periodic tables you can think? Oh, the periodic tables you can think if you're willing to research. Think Dmitri Mendeleev, or atomic families, or ionization energy. If you open your mind, oh, the tables you'll find lining up to get learned. Oh, the periodic tables you can think when you think about chem. Chem. Chemistry.
Are you done?
Oh, the elements you can find. Any chemist who researches can come up with a few.
Oh, the tables you can find.
Make a trip on a ship to the atom of hydrogen or to electron level 1. Think of beautiful elements.
With the electrons around?
You don't need an excuse. Oh, the tables you can think when you think about chemistry.
Chem.
Think of the chemist lumbering through.
Dmitri!
Yes, Dmitri Mendeleev.
On 1869, in the country of Russia, in the stress of the day, in the cool of the lab, he was researching, enjoying the labs of great knowledge. On Dmitri the chemist,
Dmitri the chemist.
Dmitri the chemist, painted a small table. So he made the periodic table that's in Mr. Remy's room?
Nope, but he created the idea that future periodic tables will be based on.
Cool. This might be a table like I read of in the books, connected with all kinds of elements to a group of elements that start here and goes right through the middle of this table. And I know everything's elements. It's all of the elements.
It might go along down where no one can see, right next to atomic mass 209, right under the noble gases, right under the toes of the halogens, who are gassy as well.
It's elements.
Everything's elements. This might be a group now, mightn't it be? Connecting the metalloids with the non-metals.
They all sound the same. How do I tell them apart?
Well,
No, we're not recognizing song.
the metals are in the middle of the table, spanning from group 1A, excluding helium, to group 2B. The metals after that are aluminum, gallium, indium, thallium, tin, lead, and bismuth. Metals' properties are being shiny, hard, high in density, heavy, high tensile strength, high melting point, and good conductors of heat. The metalloids border the metals on their right side and the noble gases on their left. They have elements in groups 3A, 4A, 5A, 6A, and 7A. Properties of metalloids are being solid at room temperature. Some metalloids connect as electrical conductors under the right circumstances. Some metalloids appear shiny, but are not very malleable. And finally, the nonmetals are found in the top left of the table, in helium, and take up the entire group of 8A. They're in group 7A with fluorine, chlorine, bromine, and iodine. They're in group 6A with oxygen, sulfur, and selenium. In group 5A with nitrogen and phosphorus. And finally, in group 4A with carbon. Properties of nonmetal are high ionization energies, being poor thermal conductors, poor electrical conductors, being brittle solids, not malleable or ductile, and being dull enough, although they can be colorful, Citizens of Mr. Remy's class.
Y'all know how bored you feel after hearing that long speech.
So be prepared for the hive mind to convey the next topic to you.
The alkaline metals, the alkaline earth metals, transition metals, halogens, and noble gases are all families in the periodic table that share similar properties within themselves.
Properties of alkali metals are low melting points compared to other metals, being soft and easily cut with a knife and having low densities.
Properties of the alkaline earth metals are being very reactive, not found freely in nature, present in the Earth's crust, but not in their basic form. Distributed in rock structure to electrons in the outer shell, high boiling points, and low density.
Properties of transition metals are typically forming colored compounds, being good conductors of heat and electricity, very malleable, less reactive than alkali metals, and they have high melting points.
I'm gonna try and do it like him. Properties of halogens are relatively low melting at the room temperature. The halogen spans the physical states.
Properties of noble gases are being odorless, colorless, and having very low chemical reactivity. Now be honest. Who's more boring, us or Mr. Remy?
Who?
We haven't broken out in song in a while. Maybe after this topic. It's too long to fit into the spoofs.
So what's the next topic, Chemist Jeff?
Well, Bob, it's atomic radius, ionization energy, and electronegativity.
Wow, I'm glad we didn't break into song. What are they?
Where to start? One at the beginning. Atomic radius is the distance from the nucleus of an atom to its outermost electrons.
Well, that's not confusing.
No, but ionization energy might be. That's the amount of energy it takes to remove an electron, or valence electron completely from the atom.
Like just taking it out completely?
Throwing it out. And lastly, electronegativity is the measure of the tendency of an atom to attract a bonding pair of atoms.
Wait, Chemist Jeff. I thought you were teaching me about the periodic table.
Attract a bonding pair of atoms.
Wait, Chemist Jeff. I thought you were teaching me about the periodic table. What does any of this have to do with that?
I'm glad you asked, buddy. They have to do with the periodic table and how it's organized. The smallest atoms are in the upper right hand of the corner of the table, and the largest are in the bottom right.
Okay, but still, what do these concepts have to do with the organization of the elements?
The atomic radius gets smaller as you go right across a period. This is because as you go across, you add an electron and a proton, which adds more pull, making the radius smaller. And it also works opposite, where it gets larger as you go down.
Ah, that must mean with ionization energy, the amount of the energy required to remove an electron increases as you go right and decreases as you go down. This is because the smaller the atom, the electrons are the closer to the nucleus, so it's a bigger pull. It also works opposite because the electrons are further away from the nucleus. The pull isn't so big. It requires less energy.
That's right. And lastly, electronegativity increases as you go right on the table and decreases as you go down. This is because an atom with a smaller nucleus is more attracted to electrons, and larger nuclei are less likely to attract more electrons.
Thanks, Chemist Jeff. You taught me so much. Now I'm Chemist Bob. Wow. So what are they?
Where to start? One at the beginning. Atomic radius is the distance from the nucleus of an atom to its outermost electrons.
Well, that's not confusing.
No, but ionization...
I'm recording for a project! Give me a hug. Hold it in.
Now be honest, who's more boring, us or Mr. Remy?
Who?
Cut. Now be honest, who's more boring, us or Mr. Remy?
I don't even know who you're talking about.
We haven't broken into song in a while. Maybe when we finish this topic.
So what's the next topic, Chemist Jeff?
Cut. It's got a line.